Hi everyone. Today's topic will be about logistic regression. In our earlier classes, in our earlier videos, we had already learned about what is regression and when we use this regression analysis and the difference between correlation and regression. And in the regression, we are having some kinds of regression analysis. One is linear regression, and second one is multiple linear regression, and third one is logistic regression. Linear and multiple regression are already there in our previous videos, and now the third type of analysis in the regression analysis is logistic regression. So the regression will mainly used for the relationship between two or more variables. So in this regression, we had already seen about linear regression and multiple regression. So the linear regression is for to check the regression analysis between two variables, one dependent variable and another independent variable. That time we use the linear regression analysis. Multiple regression is for one dependent variable and two or more independent variables. That time we use the regression analysis of multiple regression or multiple linear regression. And the next another kind of regression is logistic regression. So what is logistic regression? So let us see what is logistic regression. So this all type of regression analysis, this logistic regression is a predictive analysis. So same type of regression analysis what we are using in the linear and multiple regression, this logistic regression also we use it for the prediction. So this is a predictive analysis. In this logistic regression, we use it to describe the data and will explain the relationship between one dependent variable and also and and one or more nominal or ordinal interval or another independent variables. So, so what is the use of this logistic regression for us? So this is mainly used to predict the dependent variable, to predict the dependent variable, and it's used when the prediction is like, for example, yes or no, or true or false, or 0 or 1. Like this type, we will use this regression analysis. For one type of question, we need to follow the questionnaire type analysis, yes or no, or true or false, like that. For example, we can see insurance companies decides whether or not to approve a new policy based on a driver's history. Based on the driver's history. So they are following the yes or no type questionnaire to use that to follow the that event. Means in that credit history and other factors also will affect in that. So, and also we can see another example. For example, if a person will default their credit card payment or not. To find if a person will default their credit card payment or not. So, the probability of a person defaulting their credit card payment can be used on the pending credit card balance and income, etc. So, then we say that the person will default their payment. So, like this type of examples we can consider for this logistic regression. So, if you want to go through deeply about this regression analysis, first of all, we should be thorough about linear regression analysis also. So, what is that main difference between this linear and logistic regression? First of all, we need to know about that. So the linear regression is used for solving the regression problem. That is the common thing. So the logistic regression is used for solving classification problems to predict the analysis. So in this linear regression, we predict the value of continuous variables, but whereas in logistic regression, we predict the values of categorical variables. So that is the main difference between linear regression and this logistic regression. So these two are very important regression analysis and both are nearly similar, but there is a difference in between that. So the main differences we can consider for this linear and logistic regression is the linear regression is used to predict the continuous dependent variable using a given set of independent variables. But whereas in logistic regression, we use it to predict the categorical dependent variable using a given set of independent variables. So this linear regression is used for solving the regression problem. The logistic regression is used for solving classification problems. And also in linear regression, we predict the value of continuous variables, but in logistic regression, we predict the values of categorical variables. And also in linear regression, we find the best fit line by which we can easily predict the output. So we will find the best fit line in the linear regression. But whereas in logistic regression, we find the some curve that is like S-shaped curve by which we can classify the samples. Here we can see the curve, S-shaped curve. So this we will use it for which we can classify the samples. So these are the main differences between linear and logistic regression. So in linear regression also we must be have a continuous values. Like for example, earlier example what we have used like salary, and salary is a dependent variable, and age and his educational level and his hours work, those are independent variables. So in this linear regression, we must be having continuous values of independent variables, but in logistic regression, we must be having a categorical values like yes or no or 0 or 1. Either we predict this curve or that curve. So like that, we finally analyze by using this S-shaped curve. But in linear regression, we follow the best fit line which we can predict. And but in the logistic regression, we predict that dependent variable lies within the range of 0 and 1, means yes or no type. Like that line, we will choose for to predict that analysis. So that is about the difference between linear regression and logistic regression. And also, this linear regression, the logistic regression is a one type of technique that can be used for traditional statistics. Okay, and we understood the difference between this linear and logistic regression, right? So the linear regression, there is a fixed line to it. With that line, we could do a lot of things by using this fixed line, and we can calculate R square, and we can determine if those independent variables are correlated with that dependent variable or not. That also we can see, and also we can check the large values imply for that large affected data also we can check in that. And next, we can calculate the p-value to determine if the r-square value is statistically significant or not by using this fit line. And also, we can use this line to predict those independent variables for the given dependent variable also. And in this, we can also see that the independent variables what are there, those we can predict from the dependent variable by using this straight line, by using this best fit line. If there is any other new independent variables are added also, here in this we can simply find out the best fit line also in this linear regression. And this is about linear regression, but in the multiple regression we already know that we are having two or more variables. Like salary is a dependent variable, age and the working hours and his educational level, those are all independent variables. Two or more independent variables. Then also we can check the we can find out with the calculation of r square and we can calculate the p-value, and we can predict those independent variables like educational level, age, and the working hours of those independent variables. So, in linear regression and multiple regression also, we can follow, but slightly there is a difference between all kinds of regression analysis. And this, we already seen that this logistic regression is similar to this linear regression, and there we can also say that like instead of fitting a line to the data, instead of like this fitting a line to this data, this logistic regression fits an S-shaped curve logistic function. So this is a one type of S-shaped logistic function. Here we can see. So by following this S-shaped bell curve, we can predict the analysis for that. For example, we can say take the same example of dependent variable of salary and independent variable of age and educational level and the hours affected. So the salary in this dependent variable, we can say that the salary is affected and the salary is not affected. We can take, there are 2 points here in the dependent variable. Then we can predict whether something is true or false for this dependent variable. Like this working hours are affecting the salary or not. Like this, we will check in this logistic regression. So here we can see the curve. The curve goes from 0 to 1 point. From independent variable y equal to 0 to the point 1, like y equal to 1. And that means that the curve tells you the probability that um, a salary is based on its independent variables or not. Suppose if we added more extra hours of independent variable, then there is a high probability that new added working hours are affecting the dependent variable y. So the curve shape may get increased. Like that, we can draw the same shape but when we added the independent variable of working hours increased. So the shape, it can move here like this same when the hours are increased, the independent variable of hours increased. So like that, we can analyze the analysis. And also we can see that we also use the residuals to calculate the R square. So in this logistic regression also, we also use the residuals, same like a linear and multiple regression, we use to calculate R square, and we can compare simple models to complicated models also in this. And logistic regression, it doesn't have the same concept of a residual. So it cannot use least squares and it can't calculate R square. In linear regression, we are doing the same calculation of R square and also p values and also calculating the concept of residuals and all. But in logistic regression, we doesn't have the same concept of linear regression like residuals. So it can't use the least squares and it cannot calculate the R square in the logistic regression. Instead of that, we use something called maximum likelihood. We use maximum likelihood to predict the analysis, and we also use that to calculate the likelihood of the this salary of affecting the non-salary which were affecting with the working hours. So if there are more extra hours, then the salary of the independent variable is affecting or not. So like that, we will check in this logistic regression by following the maximum likelihood concept. And then you can calculate the likelihood of uh, the salary which was affecting with this independent variable. So, and also we can multiply all of those likelihoods together. So, whatever the likelihoods, how many working hours are increasing, those hours we will mention here. And for the salary, with the salary, and if there is no salary, when the hours also increased. So, that time we can check with this maximum likelihood. So the salary is affecting for this independent variable when hours are increased or not. So that's the we will multiply all those likelihoods together. When the salary is increased, when the hours are increased, the salary also increasing or not, or it is decreasing, or there is no salary for that extra hours worked. Like that, we will check and we will make some more S-shaped curve when the hours are increased and decreased. Then we can multiply all of those likelihoods together. That's the likelihood of the given fit line. So then we can shift the line and we can calculate a new likelihood of the data. If that predicted analysis is not coming true, then again we can shift the line to calculate the new likelihood of the coming data of the given data of independent variable and the salary of affecting. So finally we can say that the curve with maximum likelihood will be selected. For example, we can see like there is a line. This is y-axis of dependent variable, and these are the independent variables. Here are the working hours affecting. Working hours we will mention 4 hours, 6 hours, 8 hours, like that we can mention here. And here the salary when it is 0 and the salary when it is increased, means this is a salary. If here we can see that the points of the hours working. So then according to the data, the shape will go on like this. When there is a 0 salary and when the salary is increased, when hours are increased, there we can see the shape. It goes from 0 to 1. 0 to 1, the shape is going. And if you want to check with the other likelihood, when the hours are decreased more or when the hours are increased more to get the salary, so there we can draw some other likelihood lines for the given data. If the data was here, let us assume if the data is here, we can draw the same S-shaped curve with the likelihoods of the data. See, based on some other data, when the hours are decreased or increased, we again get some other S-shaped curve. So like that, we will get some type of curves like same from 0 to 1, and we need to multiply all of those likelihoods together, and for the given data of these values, then we can shift the line and we can calculate the new likelihoods like this. So then the curve with maximum likelihood will be selected. So here we can see this is only the maximum likelihood. So this curve only selected. So this is having maximum likelihood. Then we can choose this value only to predict the analysis of salary is affecting or not for the working hours. So this logistic regression this ability to provide the probability, and they can classify the new samples using continuous and discrete measurements, and then it makes it a popular value what we can consider. So in this we can this logistic regression having the ability to provide the probabilities, and we can classify the new samples what we were selected according to the data, that samples using continuous and discrete measurements. Those makes it a for the predictive analysis for this logistic regression. So as of now, we understood that the difference between the linear regression and logistic regression. The linear regression, with this linear regression, we find the best fit line between the dependent variable and independent variable. And in the logistic regression, uh, we can see that how the line is fit to the data. And with the linear regression, we fit the line using least squares also. Like that, we will check the difference between the logistic and linear regression. And this logistic regression can be used to classify the samples, and it can also be used to assess what variables are useful for classifying the samples also. So it can be used for to assess the variables or which are useful for classifying the samples. So for the dependent variable or salary, and what type of variables are useful for to classify these samples. Like we can take some other dependent variable as a educational level. What his educational level is affecting the salary of the dependent variable. So like that in logistic regression, this in this we can classify more samples for the independent variables. And we will use the logistic regression calculation by following this formula. Log of y by 1 minus y equal to b0 plus b1 into the independent variable plus b2 is another independent variable plus b3 into another independent variable. So like that we will calculate the uh, logistic regression by following this formula. This logistic regression, it also tells about the probability that the hours are affecting or not, and and his educational level is affecting or not, and his age is affecting or not for to get high salary. So it is mainly used for the classification. And for example, we can see that if the probability of working hours are increased, means that is like greater than 50%, greater than 50% was increased, then we will classify that it's affecting, otherwise we will classify that it's not affecting. So like that we will conclude the analysis in the logistic regression. Just like the linear regression, we can make a simple model like salary is predicted by the working hours or his educational level, and also for the more complicated models also we can use this logistic regression. So, and in other words, we can say that just like linear regression, the logistic regression can work with the continuous data, continuous data, and also discrete data. Continuous data means whatever the continuous data we are getting for the dependent variable to independent variables, and discrete data means by following the more independent variables. So for this complicated continuous and discrete data also is possible in this logistic regression. So these are the main differences between linear and logistic regression, and the use of logistic regression. For example, we can see some examples like predicting loan default. So, if you want to predict the loan, if you want to uh, predict loan default. So, for example, we can consider where you are working for a bank and you want to predict whether a loan applicant will default on their loan payment or not. So, like this type of questions, we will use this logistic regression analysis. And for this example, you have the historical data with the features like credit score, annual income, and loan amount. For you want to check out and you want to predict whether the loan applicant will default on their loan payment or not. So in this, the independent variables are credit score, annual income, and loan amount. And the dependent variable is the target point is loan, the loan default, the loan default. So shall we pay the loan or not? So you will build a logistic regression model using the historical data, what's there. And after that, you can use the model to predict the probability of a new loan applicant defaulting on their loan based independent variables. Those are like credit score, income, and loan amount. Based on those independent variables, you can predict whether you can accept the new loan applicant or not. So in this, you will calculate the coefficients and then you can the values what are there that features with a new applicant and calculate the probability of loan default using the logistic function. If the probability is above a certain threshold, then you might classify the applicant as potential defaulter or not. And also we need to keep in mind that this is a simple example, but in the real world logistic regression models involves more parameter tunings and validation steps will be there. And another example, we can see how logistic regression can be used in statistics. For example, to predict the customer churn. Say, for example, you work for a telecommunications company and your company is concerned about losing customers. So, you want to build a model to predict whether a customer will churn or not based on certain factors. So, the dependent variables customers why they are losing the customers. That is the dependent variable. And what are the independent variables for that we can guess like monthly charges based on the contract type. Contract type means month to month or for 6 months, 1 year, like that they will recruit. And the number of customer service calls. So based on those independent variables, we can predict and you will gather some historical data on the customers whether they churn or their monthly charges or contract type on the number of customer services calls they made. So then you decide to use the logistic regression to build a predictive model. For that, the first step we need to follow is data pre-processing. Means in this we are having the data, historical data, and we need to handle that whatever the missed values are there, and we can convert that categorical values like contract like that in that, and next we will build a model to that, build a regression model using the historical data, and we can estimate the coefficients for each feature. Okay, then after we can model the training, means the logistic regression model is trained using an algorithm like maximum likelihood estimation to find the coefficients that maximum likelihood of the observed outcomes. So what are those maximum likelihoods that you need to check? And next, you need to evaluate that model performance using some metrics like accuracy, precision, recall, and you can use the F score or F test also and a test of data set for this evaluation. And next we can predict. And based on this evaluation, we can use to predict whether the new customers are likely to churn, or you put your input their monthly charges, contract type, and the number of customer service calls into that model. So then it gives you a probability of churn. And also we can fix a threshold setting also. You can set a threshold point to classify the customers they are likely to churn or not. And if the predicted probability is above the threshold, then you can predict the about the employees. You can predict no churn model. It provides insights into the factors are strongly associated with the customer churn. And also with this, it might reveal that the customers with higher monthly charges and who are on month-to-month contracts are more likely to churn. So, based on this example, we need to keep in mind that, and also there is a lot more involved in that data pre-processing, model tuning and evaluation and prediction. So, the main goal is to build a model that helps the company and to identify potential churners and take proactive steps to retain them in the company. So for these types of analysis, we mainly use this logistic regression analysis. So the logistic regressions, the main ability is to provide the probabilities and can classify the new samples using continuous and discrete measurements by using the historical data and can make it a popular method to do the analysis. And we can use this logistic regression function by following this formula. And this function is also called as sigmoid function. So this we use the relationship between one or more independent variables. So we can define it as p of y equal to 1 by x equal to 1 by 1 plus e power of by adding all independent variables with the beta values. So here we can say p equal to p within the bracket y equal to 1 by x is the probability of the event occurring, and that x1, x2 and so on are independent variables and beta values are the coefficients estimated by the mold, and e is the base of the natural logarithm. So this formula also we can use for to calculate the for to do the logistic regression analysis. So this is about linear and logistic regression difference and where we use the logistic regression and what are the main differences between linear, multiple linear and logistic regression, and what is the purpose of using the logistic regression, and by based on some of the examples how we can use this logistic regression in business organization. Two examples are also explained in that. So this is about logistic regression.